Hey guys, we are going to go over your Saxon 107. So on the front it says draw a 1 3/4 inch line segment. Make it 1 inch longer. How long is it now? So that would mean we had 1 whole inch and then 3/4 pieces of the next inch. So it would look like this. We would go to 1 whole inch. And then 3/4 of the next inch. So there is 1/4, half, and 3/4 right here. Then they ask us to make that 1 inch longer. So I'm going to just add 1 whole inch to that. So if we go from 1 3/4 inches up a whole other inch, now it would be 2 3/4 inches. Here we have a word problem, and they've given us plenty of workspace here, so we're going to take a piece at a time and make it a picture. Ken collects stamps. He can put 5 stamps in each row in his book. So here's a row, 1, 2, 3, 4, 5. 5 stamps in a row, and there are 4 rows on each page. So here's a row of 5, then we would have another row of 5, a third row of 5, and a 4th row of 5. This is starting to look like multiplication because I see 5 a lot of times. How many stamps can Ken put on a page? 5 stamps per row times the 4 rows would be 20 stamps. On number 2, there are 6 red crayons, 2 yellow crayons, 3 orange crayons, 8 blue crayons, and 3 green crayons in a box. If you take 1 crayon out without looking in the box, which color are you most likely to get? The word most is very important there. Which color has the highest quantity in the box? There are 8 blue ones, so it's most likely that you're going to pull out a blue crayon. Which color are you least likely to get? Least is our key word here. Which color has the least amount in the box? That would be yellow. So it's least likely that you're going to pull out a yellow one because there are not as many in there. What color would it be impossible to get? Impossible means not possible. There's no way that it could happen. Impossible would be a color that's not in there at all. So it would be impossible to, let's say, pick a purple crayon because there are no purple. But you can pick any color that's not in this box. Which colors are you equally likely to get? There's the same amount of orange and green, so they have an equal likelihood of being chosen. On number 3, they tell us that 5 children will share 20 cookies. So in my workspace, I have the 5 children, These 20 cookies are going to be divided among the 5 children. So we want to know how many cookies each child will receive. If I take 20 cookies and divide them among 5 children, each child is going to receive 4 cookies. Because 4 times 5 is 20, so 20 cookies divided among the 5 children means each child will get 4 cookies. So writing the division problem, and I just wrote mine right out here to the side. Number 4 tells us the cost of the eraser is 18 cents. You give the clerk $1. How much change will you receive? The change always means finding a difference between what you paid with and what you actually owed for your item. So I've set this up with the $ and decimal. So instead of 18 with the cent sign, I've put decimal 1/8. If the bottom is bigger than top, to my neighbor I will hop, but this neighbor doesn't have any money. So I hop to the next neighbor. I borrow from the left and carry to the right, but I'm not back in home base yet, which is the ones place. So I borrow again. That 10 becomes a 9. I carry to the right. Now I can do my subtraction. 10 minus 8 is 2. 9 minus 1 is 8. I drop my decimal straight down and I have no whole dollars. So the clerk is going to have to give me back 82 cents. Because the eraser cost 18 cents and I gave her a $1 bill. So I paid 82 cents extra and she owes me that back in change. So what coins will I get? There are a couple of ways you could build 82 cents. We're going to use the fewest amount of coins possible. So 3/4 would build 75 cents. Remember when we skip count by quarters? 25, 50, 75, 100. So we have 25, 50, 75 cents so far. A nickel would get us to 80 cents, and then 2 single pennies would get us the 2 cents more that we need. So 3/4, a nickel, and 2 pennies. You may have chosen a different combination of coins to build yours, and that's fine as long as it adds up to 82 cents. On number 5, write this the way you would on a check. So we're going to write it in words. So I've built my place value house around this number. Remember we have to the left of the decimal ones, tens, hundreds, then our thousands family starts. And then here's our thousands family, the 1,000s, or we just call them thousands, and the 10,000s. So we would read and write this number 51,240 and 16 cents. Double check yours, and 40 is a commonly misspelled word, so make sure you spelled it F-O-R-T-Y. On number 6, we have to decide greater than, less than, or equals. And before we do that, we need to have a quick lesson on multiplying by 10, 100, or 1,000. We know when we multiply by 10, we just take that number and stick a 0 on the end. And that means 62 sets of 10, or 620. Well, when we multiply by 100, because there are 2 zeros in 100, we're saying 62 sets of 100. We put 2 zeros on the end because that is going to be 6,200. And if we do 62 times 1,000, because there are 3 zeros in the number 1,000, we put 3 zeros on the end of our number. 62 sets of 1,000 or 62,000. And from the right, we always go 1, 2, 3, and then our thousands comma. So this will be the ones, tens, hundreds, then the thousands family starts. 2 thousands, 6 10,000s. So here, 62 times 1,000, we would do 62 and 3 zeros. And then 584 times 100, there are 2 zeros at the end of 100. So I take that 584 and add 2 zeros. So it's 1, 2, 3, and the thousands comma. Which is bigger, 62 sets of 1,000 or 58,400? So our symbol should look like this to compare that number statement. On this one, square roots, what multiplication double would get us 64? That would be 8 plus 7 times 7 gets us 49, so its square root is 7. So this side has a value of 15. Now I'm doing 150 divided by 10. When we divide by 10, we take off how many zeros? So we would just mark that 0 off. 150 divided by 10 is 15. So both sides are equal. On number 1, it tells us Elizabeth put her pictures in an album. She can put 2 pictures in each row. There are 3 rows on each page. So here I drew my picture row 1, row 2, row 3. And each row can have 2 pictures. This is already looking like 2 times 3. How many pictures can Elizabeth put on a page? 3 rows times 2 pictures per row would mean she could put 6 pictures on each page. On number 2, there are 4 red crayons, 9 yellow crayons, 6 purple crayons, 2 blue crayons, and 6 green crayons in a box. So I've come out to the side here and I've organized that information. If you take one crayon out without looking in the box, which color are you most likely to get? The color that has the highest quantity in the box is yellow. Which color are you least likely to get? The color that has the smallest amount in the box is blue. What color would it be impossible to get? Not possible. It would have to be a color that's not in there at all. So I chose black, but any color that is not in the box would be impossible. Which colors are you equally likely to get? Purple and green have the same possibility of being chosen because they each have 6 in the box. On number 3, 3 children will share 15 cookies. How many cookies will each child receive? So I've drawn my picture here. Here's the box of cookies and there are 15 in there. And those are going to be divided among the 3 children. So we're taking 15 cookies, dividing them among the 3 children, so each child will get 5 cookies. Number 4 says the cost of the eraser is 83 cents. You give the clerk $1. How much change will you receive? So we have to find the difference between the $1 we paid with and the 83 cents we actually owed. So we're going to line our decimals up. We have to borrow across, and we end up needing 17 cents back in change. And you can build that in a couple of ways. I built it this way. 1 dime gets us 10 cents, plus a nickel gets us to 15 cents, plus 2 single pennies builds the rest of the 17 cents and change. We are eventually going to do a different method for calculating change where we actually kind of count backwards or count up, and we'll be practicing that. But for now, it's a good opportunity for us to practice our borrowing skills. On number 5, they have given us this number, and they want us to write it in words like we would say it. So this is $70,309.27. So when we write that in words, it looks like this. And they're trying to trick you with the 309, because when we look at this, this is the ones place, the tens place, and the hundreds place. So if the 9 was here, it would be 390 because we would have 9 sets of 10. But it's 9 ones, 9 single units. So we would say $70,309.27. On number 6, we have to look at the zeros. There are 2 zeros on the end of the number 100. So when I multiply 165 by 100, I have 16,500. 2 zeros here, 2 zeros on the end. On 17 times 1,000, there are 3 zeros in 1,000, so I put them at the end of the 17, and I make 17 sets of 1,000, or 17,000. And this would be less than. 16,500 is less than 17,000. This one, we find the square root of 81, which is 9, because that number belongs to the multiplication double. And the square root of 16 is 4, so this side has a value of 5. And here I'm dividing by tens, or I'm not going to add that 0, I'm going to take 1 0 away. So 50 divided by 10 is 5. So these sides both equal.